All right, this lesson is for chapter 10, section 4. It's going to be the last section that we do in this chapter before a test. A couple of key things you got to know, but I think still that most people would say that 10.2 is the hard part of this. 10.3 has some difficult moments too. 10.4 has the potential to be easy if you'll learn a few basic rules, but you have to pay real close attention to those rules. So let's get started. This section is called radical equations. Basically, we're going to now have equations or equals, and there's going to be a radical in it. So the square root of x plus 7 equals 16. Well, the most basic part is pretty easy. What's the opposite of a square root? Something squared. So if we can get the square root by itself, we can square both sides and it'll disappear. That's the key here. You've got to get that square root by itself. So the x is already on the left, but it's not by itself. So let's subtract the 7, and we get the square root of x is equal to 9. Whoa, that did not come out very well. All right, so now we're solving for the square root of something. Let's do the opposite and let's square both sides. The square and the square root cancel out to just an x, and 9 squared is 81. Now, here's the question I always get. Is it just 81, or is it positive or negative 81? The answer is it's just 81. There's a new rule that you need to really think about that comes up in this section, which does cause some problems. That when you're taking the square root of a number, that square root is always positive. You can't have a negative square root. Now, that seems a little contradictory from what we did back in chapter 9, because sometimes when we had things squared and we took square roots to solve, we had to have a positive or negative answer. That's a completely different situation. Remember what we started with, something squared. And there's two ways to get 4 by squaring something. It could be 2 squared or negative 2 squared. This is the opposite of that. Now we're starting with a square root and squaring to get rid of the square root. So trust me when I say this, the answer should always be positive. All right, so there's a very basic problem. We're going to get the radical or the square root by itself, preferably on the left if you can do it easily, before you square both sides and deal with what you got. Now, the more difficult ones don't always have it quite that simple. For example, sometimes you'll get one like this. The square root of 5x minus 11 is now equal to, whoops, that's an 11 there, is equal to the square root of x plus 5. All right, so you'll notice here, there's no way to get the square root by itself on one side. They both have square roots. There's no way to move it around. And I can't take something out of a square root sign by subtracting 5 or adding 11. Let me repeat that, guys. Please don't do this. When you have things inside of a square root, like 5x minus 11, you can never add the 11 to try to get it outside of the radical. It doesn't work that way. Instead, what we have to do here is just go ahead and square both sides. Since we have everything ready to square, we'll just go ahead and square it, even though we had two different radicals. Look what we end up with. Because the opposite of a square root is a square, we just get 5x minus 11 equals x plus 5. So it's really not that hard of a situation. We'll then subtract the x, get 4x minus 11 equals 5, then add the 11, and we end up with 4x equals 16, or x equals 4. And so there's a possibility there. All right, so let's increasingly get it slightly more difficult with other problems. So the first one, if you have a square root, try to get it on the left, try to get it completely by itself before squaring, then you can square both sides and finish solving. Slightly more difficult, the one we just did. Sometimes you won't have the ability to get the radical by itself because there'll be more than one radical. If that's the case, you can go ahead and square both sides and try to get rid of those square root signs. Now let's look at this next one. Now we've got x is equal to the square root of x plus 12. All right, first notice that there's a regular x and there's a radical x. So we've got two different types of variables in here. It's still an x on both, but one's inside of a square root, one's not. The key thing here is the variable in the radical, is the radical all by itself on one side? The answer is yes. So we can go ahead and square. And we'll go ahead and square both sides. But notice what happens here. X squared equals x plus 12. Now, this better start looking pretty familiar because this is why chapter 10 is after chapter 9. We ended up getting a quadratic equation, which means that we always set it equal to 0 and put everything on the left. So x squared minus x minus 12 equals 0. You could then factor it or use the quadratic formula. If you factor, you've got an AC of negative 12 and a B of negative 1, which means you'll have a negative and a positive. The factors should be fairly easy to see of negative 4 and 3. And so as you go ahead and go all the way down there, you should end up with x minus 4 times x plus 3 equals 0, which means that x has two answers. X is supposed to be equal to either 4 or negative 3. Or so you would think. And this is where things start getting difficult. You have to check for what's called extraneous solutions. And I need you to listen to the rule that I just gave you a second ago. Remember, the square root of a number is always positive. Okay? So you've got to check and make sure that you never get a square root equal to a negative number. Well, look at our first original equation here. X is equal to the square root of x plus 12. This square root here can never be equal to a negative number here. And so look at that negative 3. If I plug in my negative 3 right here, can I have negative 3 equal to negative 3 plus 12? The answer is no, because the square root of a number is never negative. And so this one, the negative 3, is extraneous. Now, this is where I lose some students that don't pay close attention. I did not say that negative 3 is an extraneous solution because it was negative. Not all negative answers are going to be extraneous. The ones that are extraneous cause a square root like this to be equal to a negative, which is impossible. And so you're going to have to keep that distinction. All right, so let's try another one, give you a little bit more practice. This is the part that's going to be difficult on this particular assignment. And if you're struggling understanding which answers you should or should not accept, send me an email. Let's spend a little bit of time in tutoring, and I'll do some extra problems with you in addition to helping you on your Math Excel to make sure that you understand it. The key rule, and the one you need to be thinking about, is square roots can never equal a negative. In fact, if you put the square root of 9 into your calculator, please notice it does not say a positive or a negative 3. It only gives an answer of 3. All right, so let's try this problem. We get the square root of 3y and then plus a regular 8 outside the square root is equal to a 2. All right, so we've got a single radical. We want to get it by itself on the left and then square both sides, right? So minus 8 minus 8. And we end up with the square root of 3y equals negative 6. Now stop here. And remember the rule. This would be a star in your notes. It would be a huge, big one. It's the most important thing. You might even want to write it down if you want to remember this for the test. A square root can never be equal to a negative number. Do we have a square root here equal to a negative number? Yes, we do, which means there is no possible answer for why this is impossible. The answer is no solution. Now stop and try to figure that one out. If while you're doing these problems, you come up with a problem that gives you a radical or a square root equal to a negative, it actually shortcuts the problem and makes it an easier problem to finish because you're done already. The answer is no solution. All right, let's look at those. Make sure you've got a good understanding of how it works. Get with me if you need a little bit of help on it. This assignment is not going to be due until Friday at 4, so I've given extra time. And then also look on Friday for another Math Excel that's going to be a review Math Excel that will allow you to do a practice test multiple times over and over again if you want to make sure you're prepared for a test next week. All right, guys, have a good week. Hope everybody does well.